Good morning, good afternoon, or good evening, wherever you may be in the world today. Welcome to today's VSS Monitoring webinar. Excuse me, one in a series of webinars that we're doing that are oriented toward helping enterprise and service provider customers tame the network challenges in their high-speed networks, whether it be for performance monitoring or security monitoring. Today we're focusing in on how to solve those problems and address them in high-density environments in central offices and data centers. I'm Chris Reckel. I'm Vice President of Marketing here at VSS, and I'm joined with Gordon Keith, who's our Director of Product Management.
Good day to you all.
So why don't we go ahead and get started. First, just a quick review of the agenda. We expect the webinar to run about 45 minutes. We'll have about 30 to 40 minutes for the content, and then we have time set aside for a question and answer session. So if you do have questions, go ahead and using the chat feature within WebEx, send those questions to April Perez, and then we will collect those questions toward the end of the webinar and then go through that session with you. We'll also, during this session, be running some polls to understand where you are in your environment and some of the challenges you may face. So those polling screens will come up at a couple of occasions during the webinar. We strongly encourage you to participate. As we go through the webinar, here's what we'll be focusing on in terms of market needs and trends, addressing the challenges in high-density data centers and central offices, talk a little bit about our solutions, and then talk about what some of the next steps are. So why don't we go ahead and dive right in. So one of the things that we really see in today's environment is that network traffic is just growing at a phenomenal rate. What we've seen from market research reports, if you believe the folks over at Informatics Research, a firm that I've been familiar with for many years, they count port shipments across a variety of technologies. And what they're reporting is about, when you look at 40 gig shipments, port shipments, about 1.5 million ports have shipped so far in 2014. And this is 2x the number from last year.
A lot of ports.
It is a lot of ports. And then, excuse me, if you were looking at 100 gig port shipments, the expectation for 2014 is that it will be a 4-fold increase compared to 2013, and largely driven by service providers. Enterprise-focused 100 gig deployments are expected to be a factor in 2015. And then if you take another step back and look at the market, they estimate that just for 100 gig, it will be a $6 billion market by 2017. So you see the volume in traffic. This creates new demand for a networking environment, affecting service providers, enterprises, governments, and this increase in speed, this need for speed, as it were, does create new visibility demands. Right, so there are a couple of obvious ones, right? So there's been the ongoing trend for data center consolidation, which has been driving more larger and complex networks versus a higher volume of smaller sites. The drive in virtualization makes it difficult to get at those networks and that data, and application sophistication, whether it's for supporting mobile environments or more traditional application environments, is also adding to the demand. So as managers of network operations and network organizations, this creates a lot of complexity, visibility challenges. You need more performance tools, you need more and better security in order to understand how these environments are evolving and how they need to be monitored from the perspective of meeting the needs of the business. And so with that, what we want to do here is actually do a couple of polling questions. One related to current state of volume of of the network environment, and then what future plans are. So let's go ahead and get that set up. And the first question will pop up on the screen in a moment. And then there'll be just a series of checkboxes that you can select. Okay, so that whole question can now be showing up on your screen. What link feeds do you currently have deployed in your data center? And if I remember correctly, Gordon, this is one where you can select multiple choices.
That's correct, yes. We'll give a few minutes to people to respond to this one. Yeah, give a few more minutes. It's interesting to see the results coming in, so we'll present that to everybody in a second.
All right, well, we go ahead and
close the poll now.
Yep.
Thanks for everybody for participating there. Yeah, just a moment. It's just collating the results. At this stage, one of the interesting things seems to be there's still quite a lot of 100 meg deployed.
Wow.
And also it's and the whole amount of 100 gig it appears, which lines up the results we got from the webinar we did yesterday. All right, now everybody should be able to see the results now.
Yeah, so you're right. So what you see here is 27% with 100 meg, a lot of 10 gig out there with an increasing amount of 40, and a few people doing
100, yeah. It's also interesting to note the amount of 40 gig. It's almost rivaling 1 gig down, so that is very interesting.
All right, so now let's do our second question, which is oriented toward what are your plans for the future? So we'll get that question up on the board.
Okay, that's all been open.
So now we're looking at what is the highest link speed deployed in your data center.
Correct.
Right, so this is a slightly different cut of the previous answer, which allowed you like many.
Mm-hmm.
This is just oriented toward
I'll give a few more minutes for this one. This is actually has producing some interesting results. Actually started off a little bit not quite what I expected, but it's even down now, so it's doing pretty good. Yeah, just give another moment. Okay, it looks like I think everybody's got a poll has completed their job.
And here's some of the results.
Yep.
Going up to the WebEx cloud. File.
That's right. So as you can see, there's still quite a number of people out there with 1 gig as the maximum speed. At one stage at the beginning of the poll, it looked like I was leading, so I was a bit surprised that it got back to where I expected. So 10 gig, not surprising, is still the highest speed in most networks. It's interesting to see that 40 gig is pretty well deployed, and obviously just a handful of 100 gigs.
Well, so now let's take a look at that's good information. It's interesting. If you can go to the next slide. Here's a survey that was done by Enterprise Management Associates in terms of link speeds within, based on the survey they did back in, I think it was Q3, Q4 of 2013, asking similar questions of enterprise and service provider network operators. And what you can see, and actually if you think back to the first question, the results are fairly similar to what you see for the planned deployment at 10 and 40 gigs. So it was about even, as I recall, for 10 and 40 in terms of links deployed in networks.
Close,
Yeah. And here what you see is overall there's more 10 gig deployed, but if you look at where enterprises and service providers are looking to migrate their networks, you can see that now 40 gig and even 100 gig are the majority.
Right.
So as
we
we
look
look
at plans.
Right.
That's right. Sorry.
As we look forward into the next 12 months, this is certainly on the minds of corporations and service providers out there. And again, this is now it's time to get ahead of this discussion to really understand what the challenges are and get a line of sight on how performance and security monitoring issues can be solved.
Yeah. Definitely. And I would expect that the high plans on 40 gig would be largely enterprises.
Agreed.
And more the plans on the 100 gig is probably more on the service provider side.
Agreed. So let's go ahead and dive in to the next part of our session here, where Gord will walk us through some of the challenges facing these environments.
Thanks, Chris. Yeah, so obviously some of the challenges when you have a massive data center or a central office that you want to have monitoring done of, or probably several of them, more than just one. The challenges are going to be around the increasing network traffic. Is going to be driving also the needs for more visibility into your network. It's fine when you've got a smaller network, you probably have a bit more trust and certainty about what's going on, but as the data center gets larger and larger, you actually have more of a need to actually know really what's going on inside it, particularly as it gets more complex. And then, as the network speeds get up to 40 gig and 100 gig on the links, your traditional tools that you've been using just can't keep up with that speed. And really, if you talk about 40 gig and in particular 100 gig, there are not many tools that can even provide that. One, first the interface physically, but then second the actual throughput capacity. And next around the optimizing of resources in your actual data center or your central office. Space is at a premium as you build them out to support more capacity and higher speeds. And then the power becomes an issue as well, because you just can't simply just keep adding more and more power usage, because apart from the power bills themselves, you probably can't bring that much power into the building, and you may even run into some sort of regulatory issues. So there's certainly key challenges.
Yeah, I think it's obviously related to data center consolidation. Like every other. So I think what that really points to, and this is just a general business trend, is that you can't continue the old way, right?
Exactly.
As you are consolidating your resources and then at the same time increasing the capacity of that network, some dynamic has to change.
Sure. Yeah.
And that only applies to the operational network, but the monitoring network as well.
Yeah, exactly. Right, and so if you're then trying to get access to the network that's the traffic that's in your network, I should say, you're obviously going to have a large number of links now that you have to access. So there's really, because you're having really too many links to try and get access to, as you traditionally have done so. Things like mirror and span ports just don't become feasible, and just having a single instance of a tool in your location is really not going to meet the needs either. Then you've got the actual amount of traffic you're aggregating from all this number of links. So because of that, you really need to have the ability to aggregate the traffic. Because of the number of links you've got, you're going to have asymmetrical routing occurring, which means you won't see both sides of the conversation on the same links, but it absolutely forces you to aggregate multiple links together. And just the use of capture cards on a single tool is really not going to, one, meet the need of doing your aggregation of multiple links. It's even probably not even going to give you full visibility on both directions on a link as well when it comes to the higher speeds. And because the link rates vary a lot, you need to have a solution that can cover all those different types of link speeds and bring them all together. And then finally, we mentioned it earlier that there's virtualization that goes on inside these data centers and central offices more and more now. And so, because the virtual machine communication is now hidden in a lot of cases, you have to have some solution to be able to address accessing that. So optimizing the huge amounts of traffic, so you've been able to access all the traffic from those various points. So then how do you actually optimize delivery of that traffic for the tools that you try to use for analyzing, for performance, or for security, or even just troubleshooting? So obviously a single instance of a tool is insufficient. By nature of the traffic really being bursty, some traffic's more bursty than others. When you aggregate or convert the speed from a higher speed down to another speed towards the tools that you're monitoring with, that particular bursty nature becomes aggravated and becomes more apparent, such that you'll actually end up losing traffic as you're trying to forward it towards the tools. And then finally, you've got multiple different tools that need to see copies of the same traffic. And in the case of passive monitoring, in the case of inline active monitoring, where you've got, say, IPS tools being used, then it's not so much about being able to send copies of the same traffic to the same tool, to different tools, but to actually be able to forward the traffic through each of these tools in series, and be able to do that in a realistic, manageable way without impacting your network's uptime.
Got it.
So right now we've got another polling question coming up. I'll present that to you now.
So what is the greatest challenge you have in monitoring your network today? So if you think back to where the challenges that Gordon laid out, really trying to get a sense for from participants in the webinar, what are some of the biggest challenges you face, whether along the lines of too many links, traffic, virtualization, or just really too many tools to aggregate the data to.
That's right, Chris. We'll just give a couple more minutes to let everybody do their polling. It's interesting at the moment because there's a good spread of spread on the poll.
We can't show this to everybody who's attending the webinar. We're watching it like it's a horse race.
That it is sometimes. Okay, I'll give another couple of moments. Right. I'll make this available to you all now. So as we can see, the first three items are actually fairly evenly balanced. It's only the fourth one that's a little bit lower on the list.
Yeah. It looks like it was a tie in the race.
Pretty close.
Too much traffic and virtualization.
Yeah, neck and neck on that one.
Yeah.
Which is not surprising, though.
All right, well, let's keep moving along here. I think the key point there is that when you look at the results of that poll, you end up seeing really the trend of what's going on in the industry as well, which is oriented towards this cycle that network operators, both at large enterprises and service providers face, right? Which is there's this drive to scale, right? We need more. It's going to be more complex because we're driving more and more of the business around the network operation. This creates a discontinuity, if you will. In other words, like we were speaking about earlier, the needs of the network to increase performance now don't align with the way that we had been managing and monitoring the network before. So there's this disconnect, if you will. And then as you move forward, it leads to, okay, well, I need more tools. I need the ability for those tools to do proper network monitoring and security. because the business is demanding more visibility. Right. So now I'm trying to solve this problem as the network operations team. Am I going to look at span ports, mirror ports? And there's a scale problem there. You just hit a wall when it comes to scalability and visibility. So now you've got an issue, this overall visibility issue, and this is where network packet brokers come in and really try to address the challenges, the limitations of the span port paths, and allow for a far greater scalability of tools within the organization as networks continue to change. Right? So the point here is that the network packet broker layer, if you will, allows for this discontinuity that was seen really early on in this process to be eliminated and just to be able to scale the solution as the network grows. And we included this quote from Enterprise Management Associates at the bottom of this slide, which really puts a punctuation mark on this problem, which is networks are going to 40, they're going to 100, but meanwhile, there really aren't any tools that can ingest, that can take in anywhere more than 25 gigs. So immediately you have this problem as soon as you need to deploy the network. So
it's fair statement.
It is, and I think so. This is the tee up for you. We're going to go back in and talk to the folks on attending the webinar today in terms of how we can be addressing these challenges.
Sure, thanks. So, we just step back and look at how traditional monitoring was achieved in the past, where people tend to think in terms of the individual links that they had to access, or maybe the individual switch elements. So they would hang off either a packet tap they would actually put on the link, or a single span port that they had on the switches, and just connect directly a monitoring tool to that to be able to see the traffic that's on those links, or maybe just in that one switching element. But that's typically not enough. So that just gives you a very localized analytics view, and it's just not practical when you've got many links. And the question whether it's even practical when you've got very large capacity links such as 40 gig or 100 gig. Right. Then the next step is really to sort of take a single or multiple links approach, where you still continue to tap them. You could actually take off span ports off span or mirror ports off switches if you want to. But the passive tapping approach is the most reliable in terms of ensuring you get access to all the traffic as you need it. And then you take this output from the tapping points into the network packet broker. Then the network packet broker can forward the traffic out to either different types of tools or actually multiple instances of the same tool to be able to spread that load. And this will address your needs for things like, as I mentioned earlier, the problems of asymmetrical routing and so on like that just can't be addressed if you're just looking at one link at a time. This will give you, it's still very localized, but at least you're getting a much better visibility into what you have with the many links that you're trying to monitor. So this will work for a number of links. And then once you've actually brought that traffic into a network packet broker, you can now do a number of other things. You can obviously convert the speed from whatever the links had in the first place. They could be 100 meg, they could be 100 gig. But you can convert the speed to whatever the tools are that you're going to forward the traffic to. You can then use packet filtering to determine, all right, I want to minimize and make the most efficient use of the tools I have. So minimize the traffic I have to forward to them, make the most efficient use of the tools that I have. So therefore, I'll actually only send the traffic of interest to those devices. So packet filtering really helps you do that. A network packet broker can do that in real time at line rate, because it does it all in hardware. So that's much better than relying on the software and the tool to try and sort that traffic out. Okay. And it also allows you to make one better use of your tools and not have to send so much traffic back towards them. And then the next step is actually optimizing the packets themselves. Because okay, you've sorted out what traffic you want to send to a tool, but quite often there's other information that you need added into the packets to help give extra visibility, such as time stamping, so you know exactly when the packets are on the wire. or even port stamping, so you know, okay, I've aggregated all this traffic from all the various parts of the network, but where did it actually come from? So having port stamping and time stamping tied into the packets is extremely useful. Then there's lots of other things such as maybe there's protocols, certain types of encapsulations or tunneling protocols that are just not understood by various monitoring or analysis tools. The network packet brokers can actually remove those at line rate and therefore open up the traffic, make it more easily available to the tools that are going to receive them. At the same time, by removing that information, you're reducing the bandwidth you've got to forward off to them as well. And then another one which is very interesting that a lot of networks have been running into is around duplicate packets. A lot of tools don't like to see duplicates when they're doing their analysis, so they may have to try and do a kind of a deduplication process step prior to analyzing the traffic. Well, network packet brokers can do this at line rate on the full bandwidth of traffic that's coming in. They can also resolve problems like fragmented traffic. Because if you've got fragmented traffic, then obviously you can't analyze those fragments properly. You also can't spread the load of the traffic properly if it's fragmented. So it is an advantage to be able to reassemble any fragmented traffic prior to forwarding onto the analytics tools, and the network packet broker can actually do that in the hardware as well. And then after that, then you can actually do the balancing of the traffic across multiple instances of tools, and you can be fairly sure that you're going to be then sending the traffic of interest to those tools, as well as getting all of the packets, even if there was fragmentation going on the network. And the final step is sort of buffering the packets. I mentioned earlier about the problem of bursty traffic. When you do aggregation and speed conversion, that you can end up with microbursts that result in packet loss. So you want some kind of an extended buffering function on the back end of the network packet broker to prevent those packets from being lost and ensure that when there is available capacity on the links towards the monitoring tools, that they will actually receive those packets. And then we talked about the ability to aggregate multiple links and handle all that traffic, and we talked about the different optimization features. And you can tie all that all together by having, if you've got multiple data centers, or if you have an extremely large data center or central office, where you have to sort of have different localized points where you're aggregating links around those data centers or central offices, but you still want to then bring it back to a more central point. Then you can integrate all of those network packet brokers as a virtual system, and they can interconnect with each other to allow the user to not have to worry about how they're interconnected and just forward the traffic from wherever the access point was in the network, in the data center, in your central office, and then say, okay, I want that traffic to go across to these other points where I've got analytics tools connected. And I don't have to worry about how do I do the interconnection that routing of the traffic. The virtual system will take care of that for you, which adds another helpful capability, which is around redundancy. You can actually now automatically rely on the system to reroute the traffic if one of the points in the middle goes down, and the user doesn't have to worry about going in and saying, okay, a link's gone down here, or a network packet broker's gone down here. I have to now manually reroute the traffic. I can do this automatically by the fact that I'm using a system. So this will actually work for your entire network, not just for one data center or just for a part of the data center. Extremely powerful. So this leads into the value of a network packet broker, and so where the network packet brokers, particularly if they're functioning as a virtual system, are then acting as a network intelligence optimization fabric, and it doesn't really matter at all what type of traffic or what type of networks you've got that you're trying to monitor. And in essence, it doesn't really matter how much, what type of tools you're actually using in your network. But the network packet brokers will actually get the traffic of interest to any of those devices and seamlessly, pretty much. So, I just realized there's something I haven't shown to you yet. Go back there. Yeah, so these are the points I was really talking to around, we've mentioned before about the ability to optimize traffic and trying to give you better visibility and the scale. So this network intelligence optimization layer gives you that ability, taking the traffic from, as I mentioned before, any type of network and forwarding it to any type of analytics tool. Okay, so we have another poll we're going to present now, which is around what are the features or functions that you see that are key for your organization.
Right. So again, this is thinking back to some of the areas that you talked about, Gordon, from the perspective of, is the need really around converting to lower link speed, filtering for traffic and interest? Do we need to be doing balancing? What are those capabilities? And I think that this question, people can make multiple selections.
That's correct.
So whether it's needing time and port stamps, removing specific protocols, packet slicing, or centralized monitoring, a number of options here from the perspective of, when you take a step back and say, all right, you think back to the last poll, a lot of the problems were oriented around too much, right? Network speed and virtualization. So then you drop down to that next level of saying, okay, so because I have all these two issues, although they were tied, and too many tools was very close behind, how do you then filter through that and say, okay, what are the things I'm really trying to solve for here?
Okay, I think we've probably collected all the results we're going to collect. So now I'll close the poll. It's interesting, when it comes up, you'll see that filtering of traffic of interest is a high need, and centralized monitoring is also a high need. Filtering of interest is certainly not a surprise. It's also pleasing to see that people recognize the need for centralized monitoring, which is not, I guess, totally unexpected either. Okay, you should be able to see those results.
Yeah, you're right. So half oriented around filtering, and then very, very close behind that, the central monitoring capabilities.
That's right. Yeah, so great. Thanks very much for contributing to that poll.